Hello, my beautiful computer science students. Welcome to another AP CSA lesson where I, Goldie, take you through Unit 3, Boolean expressions and if statements. Today's lesson is Lesson 2, where we're going to talk about the else statement. So in Lesson 1, we talked strictly about the if statement and simple if statements. Now we're going to introduce this else statement and talk about how it can help you make decisions in your computer program. So the else statement, okay? Else statements don't just happen on their own. Else statements happen with an if statement. So we call them if-else statements, okay? Else statements can optionally follow an if statement. We've seen in the last lesson where we just had regular if statements, an else statement can optionally follow that if statement. Else statements are executed when the condition in the if statement is false. The else statement does not have a condition after it itself. Okay? Else is just an else statement that will evaluate if the if statement is false. And here's the syntax for it. So we talked about the if condition, and then in that block, if the condition is true, you run those statements. Now you can have an else statement here. It's just the word else, no parentheses, nothing after it. It can have its block. And if the condition in the if statement is false, the else block statements will run. Okay, so you get an either or situation. Either the if statements will run or the else statements will run. Okay, so let's see two examples of that. So it says determine what is printed to the screen. So grade is 79.5. If your grade is greater than or equal to 50, you're going to print off passing. Else, you're going to print off failing. So you can see how with this code, either or is going to print off. Both will not print off. Okay? So it's either this will print or this will print. Since 79.5 is greater than or equal to 50, that is true. Passing is printed to the console and the else statement is skipped. Okay? So once passing prints, the else statement is skipped and the program continues on. Another example. So if number is equal to 15, and we check to see if number mod 2 is equal to 0. If it is, we print off even, otherwise we print off odd. Okay, so again, with the if and the else, only one of those things are going to print off. So 15 mod 2 is 1. Okay, if you take 15 divided by 2, the remainder is 1, which is not equal to 0, so it's false. Since the if condition is false, that statement gets skipped and the else statement is going to run, which means that odd gets printed to the console. Okay. And those are your if-else statements. Okay. So again, if statements optionally come with the else statement, and if an if has an else statement, it'll come right after the if statement, okay, like you see in these code examples here. This if an if statement is up here in your code and an else statement is down here and there's code in the middle, those two aren't related at all. Okay, an if statement, if it has an else, has to be directly followed by that else statement. Okay, and we're going to see that with these next three examples here. So here's the first one. It wants us to trace the following statements to determine the value of x after the code has executed. So we'll start off, x is 5. Easy enough. And then we'll ask a question. If x is greater than or equal to 6, okay, so is 5 greater than or equal to 6? That is false. Okay, so this if statement is false. Java will then check your next line of code and see that there is an else statement that directly follows that if statement, which means that when it gets to there, it'll run that code since that first condition was false. So x minus minus means that you're going to have 4, 5 minus 1 is 4, and that code executes. Okay, and that's your else block that executes. Okay, so since this if was skipped, this else runs. Okay. Then we reach into our next line of code. If x equals 6, does 4 equal 6? That's false. So again, that code gets skipped. Since this condition was false, and the program sees that there's an else statement directly underneath of it, it's going to follow that else statement. So 4 minus 3 is 1, and then the code is done. The value of x after all of that code has executed is going to be a 1. Okay. So again, the if and the else's, those two blocks were together here, and those were together here. In this next code, before we start tracing through this new code segment, look at how this if and this else are together. And then this if is just by itself, okay? Because an else doesn't have to follow an if, okay? So that if is by itself. So that's kind of your blocking there. X gets the value of 10. Is 10 greater than or equal to 14? That's going to be false. So that is skipped. Because that's skipped and the next block is an else block, that is going to run. So 10 is going to get 10 added to it to become 20. And that's going to be the new value of x. Okay. Then we have an if block. If 20 divided by 2 is equal to 2. So 20 divided by 2 is 10. 10 is not equal to 2. That is false. So that is skipped. Now that didn't come with an else block. Okay. So that code is skipped and then life goes on. Okay. Nothing else is run. We don't go back up. Okay. We don't go back up and run that else. Nothing like that happens. If the if doesn't come with an else right below it, it just doesn't run. So x is going to be 20 after that code is executed. Okay. And then here's our last example in this group. Okay. So I want you to notice how there's no curly brackets, because with the if and the else's, if there's only one statement in that block, the curly brackets are optional. Okay. So there's no curly brackets. Notice how we have an if statement here, and there's not an else directly following it. Okay. Which means that that is a single if statement. This if has an else following it. So these two are going to be partners there. Okay. This if does not have a partner. Okay. It does not have an else statement that's going to run if it's false. Okay. It's just those bottom two. The else follows the if statement directly. So when we have x is 5, we ask this question. Is 5 divided by 9 greater than or equal to 0? That's true. Okay. That is true. 5 divided by 9 is 0. It's integer division. 5 divided by 9 is 0, which is equal to 0, so it's true. So x gets 2 added to it. So it's true, it happens, it executes. The next question. Is 7 minus 2 greater than or equal to 0? That is true. So that if statement, because it's true, that block of code runs. X gets 1 subtracted from it. And the else statement gets skipped because the if block was true. So at the very end, the value of x is going to be 6. Okay, those are your if and your else statements. Okay, so we've gone over simple ifs. We've gone over if-else statements. The last conditional we're going to talk about is the else if. Okay, the else if happens if we have multiple conditions we want to check. We can use an else if statement. And here's the syntax, an example of the syntax. So an else if statement, it starts off with an if condition. A condition is checked. If that statement is true, this block of statements will run, and all statements with an else will be skipped, which means that all of these statements that start with an else, whether or not they have an if or nothing after them, all of those are skipped if that first condition is true. Okay? If this statement is false, okay, this block will be skipped, and the next else if condition is checked. So this is where the else if comes in. If that condition is false, the program moves on to the next else statement. Okay, so it has an else, and then you have this if condition. Okay, this is called an else if statement, which means that if that statement above is false, so we said if this was false, this gets skipped, and then we check this. Okay. If this condition is true, this statement will run, and all other blocks below it will be skipped. Okay. All other blocks that contain an else or start with an else will be skipped. If this condition is false, okay, so that means this condition was false, this condition was false, then the statements will be skipped, and the next else and else if will be checked. Okay. And if this is true, okay, then everything below that with an else will be skipped. If this is false, then the next else will be checked. And it goes in that pattern. You can have as many else ifs as you want in this chain of statements. And you can, again, optionally end with an else statement. And if all of the statements that came before it are false, this last block will for sure run. Okay? The else runs if everything else is false. But the else is also optional, even in an else if statement. Okay, let's see an example of this being used that might make a little bit more sense. Okay, so what is printed to the console with these code segments here? So let's say your grade was an 89. Okay, int grade equals 89. Let's check first what letter grade we're going to be printing off here. So you can see first it asks if grade is greater than or equal to 90. Okay. If grade is greater than or equal to 90, you're going to print off an A. Okay. Is an 89 greater than 90? No, that's false. Okay, you don't have an A. So you're going to skip that statement, and you're going to move on to the next else statement. If grade is greater than or equal to 80, you're going to print off a B. And it is. 89 is greater than or equal to 80. So since it's true, B is going to print to the console, and every other statement that starts with an else is going to be skipped. They're not going to be checked at all, okay? Because you can see here, this condition, 89 is greater than or equal to 70, okay? But because we already hit a true statement first, everything else gets skipped. None of those get checked. Even if they are true, they never get checked and nothing ever prints, okay? All of those are skipped, and then the program continues with code segments after that, okay? So the only thing that gets printed throughout that whole thing is a B. And that's kind of the beauty of an else if statement, is you can check different conditions. Okay, here's another example. Okay, now we have a few mixture of things. You see we have an if, else if, and an else. Okay, so let's go through and trace this carefully to see what code segments are going to be running and what code segments are going to be skipped. So the word example is our variable. It's going to have the value of 3. So this first one, example greater than or equal to 3, that is true. Okay? Because that's true, this statement is run. It becomes a 4. And anything under it that starts with an else is going to be skipped. So you can see we skipped that. This statement starts with an if, which means that it's going to jump to this line. Sorry for my inaccurate lines there. It's going to jump to that line, and it's going to start with that if statement next. Okay, now there is an else down here, but it's not going to skip that. It's going to skip everything immediately after it that starts with an else. Okay, it doesn't even look at that yet. We're not on that yet. We're going to skip to right here. If example greater than or equal to 5. Okay, it's not. 4 is not greater than or equal to 5. That is false. And that statement inside gets skipped. Now after that, there's no else statement that immediately follows it. It's just a next if statement, okay? Which means that the if statement is going to get checked. Anything that starts with an if is automatically going to get checked, okay? Example greater than or equal to 6, that's false. And because that if statement has an else immediately following it, that is going to run. Example is going to get 1 added to it, so it's going to become a 5. And then at the very end, we print off 5, since that's what's going to get printed to the console. Okay, good stuff. Next, we're going to talk about nested conditionals. We've seen one example in the last lesson, but we're going to talk about them a little bit more right now. Conditionals can be nested in one another to make multiple decisions in a program. Okay. Tabbing is very important with nested conditionals to keep everything organized. Okay, so by convention, we like to tab in a program. Tabbing is not required for a Java program to run, but keep everything organized and include your tabs. Please, for the sake of my eyes, keep everything tabbed. Okay, let's start off with a simple nest here. A gets the value of -5, B gets the value of -10. Okay, it says if A is greater than -10. So is -5 greater than -10? Thankfully, that's true. So then we move inside that if block. So you see we have an if block right here. We move inside and we reach a couple statements in here. The next if says if B is less than -10. That's false. Okay. So inside this if statement, we skip it and we move on to the next statement, which is printing off a B. So the letter B gets printed off. Okay, because this if statement, because it was false, it only skipped this. Okay, this still runs because this is outside of that false if statement. Okay, so keep your tabs organized, be very careful. Okay, B runs because this was true, and then we skip A because that was false in there. Okay, all right, let's see another example of this. X equals 5, Y equals 7. Starting off good. Okay. Notice the blocks you have here. Okay. We have an if statement here, and it goes with this else if statement right here. Okay. Inside each of those, we have an if statement, but always start on the outside first. Okay. I have an if and an else if, which means the if is checked first. If 5 is greater than, 5 is greater than 5, it's false. Right? So everything inside this block is going to get skipped. Okay, so you can see I crossed it all off. Everything in that block is going to get skipped. The else if is now going to be checked because it starts with an else. Else if x is equal to 5. That is true. So we move into this block. Okay? Inside this block, this is going to run. Okay? So this condition is checked. Y less than 8, that's true. 7 is less than 8. So that means the Y prints off first. Okay, because this statement was true, the Y prints off. Okay, but then don't forget about this statement right here. This is outside of the if statement, so this was going to run regardless because X was equal to 5. But the Y got printed first. Again, we're going top to bottom still. So Z gets printed off next. Okay, so you get YZ printed to the console because those are both print statements. Whew. I got two more examples here in this lesson. The next example is similar to a multiple choice question you might see on the exam, where it says consider the following code. Okay. So you have here if number mod 2 is equal to 1, print odd, else print even. Okay. So if a number mod 2 is equal to 1, so if like 21 mod 2 goes into 20 evenly, but it goes into 21 and has a remainder of 1, right? So that means that 21 is an odd number, right? Otherwise, it prints off even. Okay, so that's what the code segment is doing. Sometimes it's helpful to think about what that code segment is saying first. So then the question is, which of the following statements are equivalent to the above statements, which means that they evaluate to the same thing if the value of number is the same. So if the value of number is 21 and it prints off odd if it's 21, or if number is 20, it prints off even, which of the following code segments will do the same thing, okay, that are equivalent code? And I have 4 examples, okay? So let's look at A first. So you see A, it starts off and it says if number mod 2 is equal to 0, print even. If number mod 2 is not equal to 0, print odd. Okay. So you can see how it's trying to say the same thing as that code segment above, but it's just saying it in a different way. So it wants to know, is it going to evaluate to be the same thing? Okay. So first off, the statements are correct. Everything about the syntax is correct. If the number is 20, it prints off even. If number is 21, it's going to print off odd. It works, right? But with these examples, especially in the multiple choice, you always want to consider some of the special cases. Okay, so for example, 0. Okay, what if number was 0? Well, in the code segment above, 0 mod 2 is 0, so even would print off. Okay, so even would print off right above here. So you want to make sure the same thing happens in this code segment. What's 0 mod 2? That's 0, and even would get printed off down here. Okay, so yes, that means these code segments are the same. Okay, so saying the same thing, just slightly differently. Okay, let's look at the next one. This is the same one as A, except it has an else if in front. Okay, so notice that else. So will it still run with the else if correctly? Okay, does this change the code enough so that it's not equivalent? Okay, and the answer, again, check your 20. Okay, 20 mod 2 is still 0, even would print. 21 mod 2 is 1, so the first statement gets skipped. The second statement would run and be true. Odd would get printed. And then you can check your special cases of 0. This is still an equivalent code segment. Okay. So you're seeing multiple ways of writing code that accomplishes the same thing. Even for C, now this is interesting. We haven't seen a code segment like this before. It says Boolean flag equals, and then in parentheses, number mod 2 equal to 0, or equal to 1, right? So remember that this is a question, okay? This is going to evaluate to true or false. And because it evaluates to true or false, we can use a Boolean variable to capture that result, right? So if number was 21, 21 mod 2 is 1, 1 equal to 1, that's true. So flag would have true stored in it if 21 was your number. And then you see here, if flag, okay, you just see the variable, right? And so far, I've said we always need a comparison in there, okay? But what we really need, what we talked about in lesson 1, what we really need is a Boolean condition. And I have a Boolean there, okay? Flag is true. So if it's true, print odd, right? So if number is 21, flag is true. If flag, meaning if true, print off odd. Else, print off even. Okay. It's the same thing as the code above. It's just using Booleans now instead. Okay. And we'll use Booleans a bit more in the next couple lessons, lessons 3, 4, and 5. So this is your little introduction into it. Boolean is true. Okay. So again, it gets evaluated to true or false, the result is stored in the variable flag, and it is going to be equivalent to the code above. All right, which brings us to our last one. Okay, is this going to be the same? And hopefully you see the error right away. Okay, it looks like it would be the same, except for that syntax error. The else statement has a condition that is a legal syntax that's not allowed. So this is not an equivalent statement. Okay, so the issue here wasn't a logic issue; it was a syntax issue. Okay, so be aware of both on those multiple choice questions. Sometimes they're checking to see if you can find the logic issue somewhere, which is why we used our test cases, and sometimes they're checking the syntax. Okay. All right, our last example of the day. We're going to be writing a small code segment here. So when you go to your favorite website, their shipping is added to your total cost, okay, based on how much your total cost is, right? The table below outlines how much shipping is, and your goal is to write a code segment that assigns the correct shipping amount based on a variable called total cost that contains the cost before shipping. Okay. So we see that table, and let's try to write some code. Okay, so how do you get started writing a small code segment based on this? Well, you have to answer some questions first. Is this a series of if statements? Can this be accomplished just using if statements? Or do you have to have nested conditionals somehow? Or Do you use else if statements, right? What's going to work for here? There's several ways to write a code segment to get the correct answer here. Okay? There's not one way to write a code segment that accomplishes the goal correctly. And to show you how you might go about getting this started, let me take a moment. Let me pull up my Replit screen here, and let's show you how I might think about this. Okay, so I have my code here. I have my double total cost, and I just put in whatever. Let's say my total cost was 45.67. Okay. Now the first thing you might think of is in that table it says if the cost is between 0 and 24.99. So you might be tempted at first to write something like this. If 0 less than total cost less than 24.99, then you get $15 added to total cost. Okay, but in a question you can only ask one question, right? You can only use one comparison. So this has two comparisons, this comparison and this comparison, which you can see the compiler is spitting out an error message. That doesn't really make sense, but it's spitting out an error message because you have two conditionals in there, and you cannot have that. Okay, this is illegal syntax. So that's always what I see students try first, is almost like an algebra statement, right? If your total cost is between these two values, but it's not going to work. Okay, so next you might be thinking, okay, let me delete this one. Okay, now it's a legal statement, right? It's okay if 0 is less than total cost, or let me write that a way you probably would write normally. If total cost is greater than 0, right? Well, that's an issue, because if total cost is greater than 0, well, it also depends on if it's less than $25, that would be 15. If it's between 25 and 50, it's another price. So this isn't going to be helpful for me. Okay, so sometimes starting at the top of the table isn't necessarily the most logical way to do this. Okay, which is why you'll see sometimes starting at the top of the table, almost like we did, and it's 50 equal to 50 or higher, almost like we did with our grades, right? If your grade was greater than or equal to 90, print an A. Else if grade greater than or equal to 80, print a B. It's kind of the same thing here. If you start at the top, anything above 50, there's no upper boundary here. Anything greater than 50, you're going to add $5 to the total cost of shipping, right? So total cost plus equals $5. Okay? Total cost gets $5 added to the shipping, for shipping. Okay, perfect, that works. Now, I have to decide, do I do an if statement or an else if statement, or do I do an else statement, right? If I did an if statement, so let's say total cost greater than or equal to 25. Okay, would that work out? Total cost gets $10 added to it. Would that work out? In this case, it would not work out, because if I'm 45, well, let's say I'm 80, right? If I'm $80 in my total cost, I want 5 added to it. But then when I come here, this statement would also be checked. 80 is greater than or equal to 25, which means I would get an additional $10 added to it, which is not what I wanted. Okay, so that's not going to work out. If this is true, I don't want anything else checked. Okay, if total cost is greater than or equal to 50, I'm done. I have my shipping costs and I don't want anything else added to it. That's a good time for the else if. Okay, if one condition is true and you don't want anything else checked, go with the else if. Okay, now it's okay. Okay, because now if it's 80, this will be true, this will run, and everything with an else will be skipped. Okay, so we got the total cost greater than or equal to 25, and then we can also do an else if total cost greater than or equal to 0, total cost plus equals 50. Okay, and this would be a great way to do it. Okay, now do you need this last condition, right? Because if you're ordering from the website and having something shipped, your total cost is always going to be greater than or equal to 0. So technically, you could write this without that if statement there. Okay, you could just write an else statement, and it would run correctly. Okay. So that's just one way. Now this code segment is totally correct. Perfect. It works. Okay. That is one way to do it. Okay. And if I go back to my PowerPoint here, that's the first example I have here. So this is what we just wrote. Total cost is 5, total cost greater than or equal to 25, or else. But as I said, there's multiple ways to do this. You could have even done some nested conditionals in here, and you would have been correct. Okay. Another way I've seen students do it is like this. Okay, slightly different. They checked first if your total cost was less than 25. Okay, so if it's less than 25 right here, you're just automatically going to add 15 and everything else gets skipped. If your total cost was less than 50, okay, you're going to add 10 to it. Okay, so the 10 right here and everything else gets skipped. Or the else statement was if it was higher than 50, then you would get 5 added to it. So slightly different, another way to do it. And again, nested conditionals could have worked if you figured out how to use nested conditionals with this. There's many ways you can write code segments once you start involving conditionals. Okay, that brings us to the end of our lesson. Thank you guys so much for watching and following along, and I will see you next time.